Gummy bears may look small, colorful, and playful, but behind each chewy bite is a highly engineered confectionery process that combines food chemistry, thermal control, precision molding, controlled drying, and high-speed automation. What begins as a clear, flowing liquid syrup is transformed through a carefully managed sequence of cooking, flavoring, shaping, curing, polishing, and packaging steps. Each gummy bear must be identical in texture, elasticity, shine, flavor intensity, and weight. With billions produced every year, even the smallest inconsistency can scale into major quality issues. And today on the How Factory, we're stepping inside modern candy plants to see exactly how gummy bears are made, from liquid syrup to perfectly chewy candy. The origins of gummy candy trace back to the early 20th century, when confectioners began experimenting with gelatin as a structural ingredient. At the time, most candies relied on sugar crystallization for firmness, producing brittle textures like hard candies or caramels. Gelatin introduced something entirely new: elasticity. This protein-based gelling agent allowed candies to stretch, compress, and rebound, creating a mouthfeel unlike anything else on the market. The bear shape itself was inspired by trained dancing bears popular at European festivals, and it quickly became an instantly recognizable symbol. What began as a novelty sweet soon turned into a global confectionery category, scaled up through industrialization and automation. Modern gummy bear production starts with raw materials that appear simple, but behave in complex ways when combined. The core ingredients include sugar, glucose syrup, water, gelatin, flavorings, colors, and food-grade acids. Sugar provides sweetness and contributes to the candy's structure once moisture is reduced. Glucose syrup plays a critical role by inhibiting crystallization, ensuring the final candy remains smooth rather than grainy. Gelatin is the primary gelling agent in traditional gummies, responsible for chewiness, elasticity, and shape retention. Flavorings and colors define each variety, while acids such as citric or malic acid balance sweetness and sharpen flavor perception. The process begins in large stainless steel cooking kettles, designed for precise thermal control. Water, sugar, and glucose syrup are pumped into these vessels and heated while being continuously stirred. The goal is to dissolve the sugars completely and drive off excess water to reach a specific concentration. Temperature accuracy at this stage is essential. If the mixture is overheated, sugars can degrade or caramelize, altering both flavor and color. If underheated, the syrup will contain too much moisture, preventing proper setting later. Automated control systems constantly monitor temperature, viscosity, and solids content to keep the syrup within tight tolerances. While the sugar syrup cooks, gelatin is prepared separately. Gelatin powder or granules are mixed with warm water and allowed to bloom. Blooming allows the gelatin to absorb water and swell, softening its structure so it can dissolve evenly when added to the hot syrup. Skipping or rushing this step would cause clumping and uneven gel formation. Once bloomed, the gelatin is gently heated to form a smooth liquid and held at a controlled temperature until needed. When the sugar syrup reaches its target concentration, the gelatin solution is added. Mixing at this point must be thorough but controlled. Excessive agitation can introduce air bubbles, which weaken the final gel and create visual defects. The combined mixture becomes a viscous, elastic liquid, the foundational gummy base. This mixture is then filtered through fine screens to remove any undissolved particles, ensuring uniformity across every piece produced. At this stage, the base is still neutral in flavor and color. Flavorings, acids, and color solutions are added next. These components are dosed with extreme precision, often measured in fractions of a percent. Acids not only influence taste but also affect gel strength and shelf stability. Each flavor batch is prepared separately, allowing manufacturers to fine-tune profiles and maintain consistency from run to run. The finished gummy syrup is now fully formulated and ready for shaping. Shaping gummy bears requires a method very different from other candies. Instead of rigid metal molds, gummy bears are formed using starch molding. Large trays are filled with fine, dry cornstarch and leveled into smooth beds. Mechanical stampers press thousands of bear-shaped cavities into the starch, creating temporary molds. The starch serves multiple purposes. It holds the liquid syrup in shape, absorbs surface moisture during setting, and allows easy release once the candy cures. Depositing machines move over the starch trays, filling each cavity with a precise amount of hot gummy syrup. The nozzles are engineered to deliver consistent volume and flow rate, even as viscosity changes slightly during production. Speed and accuracy are critical. A modern line can deposit tens of thousands of gummy bears per hour, and even minor variations can compound quickly. Once filled, the trays are transferred carefully to curing rooms. Curing is where liquid syrup becomes solid candy. Trays remain in climate-controlled rooms for anywhere from 12 to 48 hours, depending on formulation, size, and desired texture. During this time, gelatin forms a three-dimensional network that traps sugars and water, creating elasticity. Simultaneously, moisture slowly migrates from the candy into the surrounding starch. Temperature and humidity must be balanced precisely. Too much moisture leaves gummies sticky and weak. Too little causes excessive drying, resulting in overly firm or brittle candy. As curing progresses, the gummy bears shrink slightly and firm up. The surface develops a thin skin that contributes to the characteristic chew. Once curing is complete, the trays move to demolding stations. Vibrating screens and air jets separate the candies from the starch. The starch, now carrying absorbed moisture, is collected, dried, sifted, and reused, making the process both economical and sustainable. Freshly demolded gummy bears are structurally complete but visually unfinished. They often appear matte and dusty due to residual starch. To achieve their familiar glossy appearance, the candies enter polishing drums. Inside rotating drums, gummies tumble gently while receiving a light coating of food-grade oils or waxes, such as carnauba wax. This step enhances shine, reduces surface friction, and prevents sticking during storage and transport. Some gummies undergo additional finishing steps. Sour varieties, for example, are lightly misted with syrup and tumbled in sugar acid blends. The coating must adhere evenly without dissolving or clumping. Other varieties may receive layered flavors or specialty finishes, each requiring precise timing and control to maintain texture. Quality control is embedded throughout the entire manufacturing process. Samples are pulled continuously and tested for size, weight, moisture content, elasticity, and flavor accuracy. Texture analyzers compress and release gummies to measure chew strength and rebound. Optical systems verify color uniformity, while sensory panels evaluate taste and mouthfeel. Because consumers expect every gummy bear to feel identical, even small deviations trigger process adjustments. Once approved, gummies move to high-speed packaging lines. Multi-head weighing systems rapidly combine small portions to reach exact package weights. The candies are dropped into bags or containers made from moisture-resistant materials. Many lines use nitrogen flushing to displace oxygen, extending shelf life and preserving texture. Packaging machines seal thousands of units per hour, printing date codes and batch numbers for full traceability. After sealing, packages are boxed, palletized, and prepared for distribution. Gummy bears are ideal for global shipping due to their long shelf life, low fragility, and relatively stable structure across a range of temperatures. Warehouses and logistics systems ensure products reach markets worldwide with minimal variation in quality. Behind all visible production steps lies a strict sanitation regime. Equipment is cleaned and sanitized regularly to prevent flavor crossover and contamination. Pipes, kettles, and depositors are designed for clean-in-place systems that allow thorough cleaning without disassembly. Although high sugar concentrations inhibit microbial growth, food safety standards remain uncompromising. Sustainability has become an increasing focus in gummy manufacturing. Producers recycle starch, optimize water usage, recover waste heat from cooking systems, and reduce packaging materials. Many are also exploring alternative gelling agents, plant-based formulations, and reduced sugar recipes to align with evolving consumer preferences while maintaining familiar textures. What makes gummy bear manufacturing remarkable is how precisely controlled chemistry operates at industrial speed. Gelatin behavior, moisture migration, and sugar concentration must align perfectly, even as production lines run continuously for hours or days. The transformation from liquid syrup to chewy candy is delicate, but the system executing it is robust and efficient. From heated sugar kettles and gelatin preparation tanks to starch molding trays, curing rooms, polishing drums, and high-speed packaging lines, gummy bear production is a synchronized process designed for consistency at massive scale. And that is how gummy bears are cooked, flavored, molded, cured, polished, and packaged, turning flowing liquid syrup into billions of perfectly chewy candies enjoyed around the world. Thanks for watching The How Factory.